Welcome again to data visualization. In this video I'm going to speak about the Seaborn Plotting package, and simply we need to import the Seaborn package using import Seaborn as SNS. SNS is a reference for the Seaborn package. Then I'm going to read the data set from the salary CSV file. As we see here, data set equal to BD Panda. We need to import Panda as well. Read CSV, then read our data, and then display the first 5 records. Okay. Now I want to use now the first method here is called strip plot. Okay, so SNS a strip plot, and then I need to pass only the x vector here, and here the x vector I want to represent and show the salary. So x equal to data set of salaries. Okay. Now, what if I would like to display salaries per gender? Okay, so here I'm going to use SNS a strip plot. Then I'm passing the vector for the x-axis here. So male and female, so I'm going to use the gender here, and then for the y-axis here I'm going to use the salary from the data set called data set. Okay, same name for the data set which we read it here. Okay, so data here refer as an attribute for this graph method, strip plotting. As we see here, that automatically Python gives these blue and orange colors for different categories which we have here, male and female. Okay, as we see here that the male got the highest and lowest package comparing it to females, but in somehow both of them are very close in terms of salary packages, as we see here in this graph or in this data set. As well, might be we would like to use discipline. Here we have A and B, and then for the y axis here I want to use the salaries, but as well I want to show the data scattered here. Okay, so I don't need it in this form. I want to scatter the data. Okay, so jitter here equal to 1, or jitter equal to true. Okay, or even jitter equal to 0.5, and convert it into a true value. Okay, so just by run it, as we see here, SNS is not defined, so might be I did not run this one, but I already. Okay, now let me try this one again. Data set is not defined. Okay, no problem. Let me refresh it again. Okay, let me refresh that one again, and here is for this one again. Okay, so here is our data set for per discipline, the representation of salary per discipline. Okay, if we convert discipline, if we swap between these x and y here, okay, if we want to represent it in a horizontal manner, so simply just swap the salary and discipline. So we want to put the discipline to be the y vector here, or x, and the salary to be the x-axis here. Okay, so, for this data set. Okay, as we see here, we just is similar to the previous graph, but only instead of being in vertical graph form, we want the data to be in horizontal form. Okay, again, as we see here, the highest salary was for discipline B, and the lowest salary was for discipline A. Okay, and we can see, for example, around 80,000 in A, more than in B. Okay, but if we look, for example, here for 160,000 in B, more than A discipline. Okay, Okay, now again, strip plot for X and Y, but I want to distribute salary by the rank which we have. So again, I have rank professor, assistant professor, associate professor, and here I'm going to distribute the salary by the rank. Okay, as we see here in our data set, that the professor got the highest packages, and then associate professor, and then assistant professor, as shown here. Okay, as well, we have many people in our data set. We have many people in the rank professor. Okay, if I want to display the legend, we can use who here, and who here refers to the legend, but I want to show the legend by rank. Okay, so here I want to display salary by gender, but I want to show it also by rank, the rank. So here I have male and female, which is the gender, and then the salary in the y-axis, and then for the data set, as we see here, all these people, male category, we have all these people. Most of the people are professors. Okay, and we have 1, 2, 3 associate professor, and we have few also assistant professor. And females also, many people are professors, and then we have also associate and assistant professor, as we see here. Okay, actually it's very good, very nice way to for graphing. Okay, now again, SNS strip plot. I want to add here the who for rank, which represent the legend here, and at the same time also I want to dodge, which means that I want to scatter. Instead of using instead of scattering here, I want to show it in a different representation. Okay, aggregated together. So here I can find, instead of putting associate, assistant, and the professor together, for female, no, we have the professors, and then we have associate professor, and then we have assistant professor. Same thing for males in terms of professor, associate professor, and assistant professor, as you see here. I think this gives a better picture than the previous one. Okay, so here we have to use SNS strip plot. X equal to what is the x vector here, x axis here, and the gender, and then for y salary, u equal to rank. Okay, and then data, our data set, jitter, which means that I want to scatter the data here, but bear dodge. Okay, okay. Now box plotting. Another way to graph or plot your data is to use the box plot. Okay, the box plot, you can find it shows to you the minimum and the maximum and the median value and the quantiles for your data, as well you can find the range for your data here. Okay, but here in this example, let me just comment this one and run it. As we see here, we have box plot the salary and the gender. Okay, the salary per gender. Okay, so I box plot the salary per gender, and as we see here, there is somehow little bit shift between male and the female. Okay, so here again the minimum and max for males is the max salaries goes for males, as well the median value, there is a shift in the median value comparing between male and the female, where it's for male is higher than the female packages. Okay, as well the percentiles here, quantiles here for 25th and the 75 quantiles are somehow for males higher than for females. Okay, what if I would like to add more information to my graph? Okay, here I'm just adding with the box plot a strip plot as well. Okay, on the same canvas. Okay, so a strip plot for salary and the gender 6 here, and the data set again data equal to true, and the color the colors here. Okay. Okay, very easy and simple way to visualize the data, and gives a very good picture about your data. Okay, swarm plot. A swarm plot, as we see here, somehow is similar to the previous strip plotting here, as we see here. Okay. Okay, but we can find somehow little bit clustering here. If you see, you can find little bit clustering in this swarm plot for your data. So here I'm distributing salary against the sex or gender, hue bear rank for data set, and plates equal to toe, and doji equal to true. Okay, so I want to split each of these category into its separate distribution. Okay, so we have here professor, and we have associate professor, assistant professor. Okay, the same for males. Okay. Okay. Now here it's the same and the previous one. Okay. But here, as we see, dot G equal to false, which means that I don't need to represent it into separate subcategories here, but we need all of them, but only bear gender, male and female. Okay, as we see here, we can find professor, associate professor, and assistant professor in representation here, and but also ranked bear the rank or displayed per rank. So we have here professor with this green color, orange color, and this yellowish color. Okay, or this bluish color. Okay. So now box plot again. You can use a box plot by passing the vector or data set that you want to display, or even you can combine more than one variable in the same box plot, as we already saw before. And you can also use the notch attribute here, as we see here, to just show your box plot in a better way, and just to see, give you a picture about these quantiles here with the minimum, maximum, and median values. Okay, so the median value somehow is around 5,000. Okay. Okay. Now here, box plot again. I have x and y, so I want to represent not only one variable or vectors. I want to represent salary and in terms of ranks. So I want to show the professor salaries for professors. I want to show salaries for associate professor and salaries for assistant professor, but using a box plot graph. Okay, as we see here, again professors are when, and then associate professor, and then assistant professor. Okay, box plot similar to the previous one, but I want to put the plates here sets into 3. Okay, so I want to show their gender. I want to show their gender, male and female. So here I have 3 plates or 3 sets, professor, associate, and assistant professor, and for each one I want to display salary, bear gender, male and female. So if we now we can, even for the professor, we can compare professor male and female, and we can compare associate professor male and female, okay, and assistant professor male and female. Okay, so as we see here, the median value for professor, even all of them in the rank of professor, but for female is lower. Okay, here is lower, also here is lower too, which means that in general for female the median salary lower than the male ones. Okay, okay, we can add again a swarm plot to box plot, so we can combine more than one method in the same canvas. As we see here, we are box plot visualizing data using box plot, salary per rank, per the rank, and then I combine with in the same graph, okay, as we already saw before. Okay, I combine or add the swarm plot here, as we see, so it can give us also a better information about the data in the graph. Okay, joint plot. Joint plot, just I'm displaying just to refresh your mind and to remember the data set which we have here. We have rank, discipline, PhD, service, sex, and salary, and as we see here, these are string data in the rank, and then for PhD and services, numerical values in years, then salary double value or the largest value or big values which we have here. So it's not possible to compare salary with service, but we can compare PhD with service. But we can represent salary against the service using a scattered plot or using any other method. Okay, now for SNS, okay, joint plot. X I want to represent salary and Y I want to represent service. Okay, then as we see here, that joint means that I want to plot more than I want to have in my graph more than one plotting. Okay, so we have here histogram, as we see here, histogram for salary, that one, and we have histogram for service, that one, and then we have the distribution between salary and service in a scattered form. Okay, so we can see that the most packages are goes around 100 around between 85 to 100,000, and most of the people, their services between 0 up to, we can see, up to 20 years. Okay, and we can see that most of our data are condensed here between somehow 70 up to 100 130 or 140. Okay, now we can add more features to the joint plot. So SNS joint plot of salary and the service. Again, I want to represent salary against the service in the joint plot. For the data equal to data set, which we already read it before, kind equal to reg. Here regression, so I want to display also or use a regression function or regression representation here in this graph, as we see here. Okay, very easy and simple way for plotting data. Okay, now we can use the same method, joint plot, to combine more than one method, but here the kind, instead of regression here, used the hexagonal. Okay, so here we can see a different method to represent the data in histogram and hexagonal representation. Okay, we can change also our kind to kind here equal to KD to show the layers of data contents. Here we have one, we will see it later for these, how many plates or layers here. Okay, another method to represent joint plot here. Okay, again here I want to have different levels for my data in the graph. Okay, so here I'm again use the joint to plot services against the salary, against the salary for data set, for data equal to data set. I want to plot joint KD plotting, but the levels equal to 6. As we see here, here is one level. Okay, 1, 2, 3, 4, 5, and 6. Okay, so again 1, 2, 3, 4, 5, and 6 levels for our data. Somehow it's very you can see that it's not a clustering but a way of representing data to discover what is the intersections, or you can find somehow better understanding for your data. Okay. Again, here is similar to the previous example, but only I'm adding here the rug plot here. Where the rug plot here, services against the salary, and the data equal to our data set, plotting joint KD plot, levels, 6 levels as we already said before, as I said. And here for marginals, I want to add the SNS rug plot. Rug plot here, if you observe here, there is some, the blue colors data representation here in the histogram, as we see here in the for the salary as well for the service here. If you look to the previous graph, nothing is shown here, so I want to add also the represented data in terms of rug to see how the data condensed of the data here, density of the data in the histogram. Okay, so again here, if you look to this graph, you'll find that somehow between 1 up to, can we say, up to again 20 or 25, this is the highest number of services people serve, between 0 up to 20. As well for the salary packages, somehow it is between, we can see it is between somehow 50, 55 up to 140 somehow is the highest packages. Most of the people, they got the package between this range. Okay, Seaborn is another library package to represent the data and visualize your data in better and attractive way, to have a good idea about the different variables that you have. It's very easy and simple. You need to just implement it using a data set, but again you have to be careful about the units of data that you are going to represent it together. If you would like to compare between more than one variable, so you have to be careful about the units of data used for your graph. Okay, I hope that you enjoyed the Seaborn and you can use it. Thank you for watching.